Okay, so next problem is going to be problem 12. We're looking at highly divisible triangle numbers. So a triangle number, it shows you right here, the first 10 of these numbers right here, so it's the 7th triangle numbers taken by adding the first 7 numbers, so 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Then once we've got these triangle numbers, we're listing the factors of them, and we want to find the first triangle number to have over 500 divisors. So what we want to do is we want to have a function that's going to return triangle numbers, a function that's going to find the divisors, and then a function that's going to, or maybe not a function, but just some way of keeping track of when we've got a new highest number of divisors. So yeah, that's about it. Let's get into it. So first of all, we're going to keep track of our current most divisors. So first of all, we want to know how many divisors we need. So we're going to have a target number of divisors. That's going to be equal to 500 in our case. Now, current most divisors is equal to 0 because we currently don't have any. Then we need some way of generating triangle numbers, so we're going to start by giving it the first one. So triangle number equals 1. Now to get the second one we need to add 2 to it. So we're going to keep track of what we're adding to it by keeping track of an index. So we're going to say index equals 2, and then we're going to say next triangle number. Sorry, no, we're not. We're just going to call this triangle number. Triangle number equals next triangle number, and this function is going to take in the current triangle number and the index. Now let's make this function. So next triangle number takes in, we'll just call this number, and then index, and what it wants to do is it wants to return number plus index. So what this is going to do is it's going to take in the current triangle number, it's going to add the index to it, and then once the index has been added to it, then we want to return index plus 1, because once the index has been added to it we want to add 1 to the index, and we're going to return that index. So we've not actually done this before, but what you can do is you can return multiple things from a function and then assign these to these different variables. So you can see our first thing we're returning is number plus index, so this is going to be our triangle number. Second thing we're returning is index plus 1, so this is going to be our new index. Now this just means we can call this function on a loop and it'll just keep iterating through triangle numbers. So now we need something that's going to return divisors. So define find divisors. Now we're going to pass this a number. Once we found this number, we're going to say let x equals 1. Actually, let potential divisor equal 1. Now, while potential divisor is less than our number plus 1, we want to say if number mod potential divisor is equal to 0, then we need a list of divisors. So divisors equals empty list. Now if we found one, we want to say divisors dot append, and we want to append potential divisor. And then once we've done all this, we want to say potential divisor plus equals 1. And at the end, we're going to return divisors. So this here is just going to take potential divisor and check if it divides into number. If it does, we're going to append it. If it doesn't, we're just going to move on to the next one, on the next number, until this potential divisor number is actually bigger than number, because then we know we've checked all the numbers below number. There's a couple of little tricks you could do to speed this up. So you could check, for example, all the numbers up to the square root of number, and then once you've found all these numbers, you could then get your other set of numbers by just taking them away. So for example, for 10, you check up to like 3, so you'd check 1, 2 and 3 to see if they divide into 10. You'd find that 1 and 2 divide into 10, and then to get the other divisors, so 5 and 10, you would just say 1 times 10 is 10 and 2 times 5 is 10, so you'd do like 10 divided by 5, 10 divided by 2 to get you 5, and 10 divided by 1 to get you 10. Hopefully that makes sense to you. We'll add that later, but for now we're just going to get this working. So what we're going to do now is we want to say while divisors of our triangle number is less than 500, we want to keep calling next triangle number. So we're going to say while true. Actually, could we put all this on one line? We might be able to put all this on one line. No, maybe not. I don't know. We'll do it this way anyway. So while true, we want to say find divisors of triangle number, and we want to say like so current divisors equals find divisors. Now len of current divisors, number of current divisors is equal to the length of current divisors. Now if number of current divisors is bigger than current most divisors, then current most divisors is equal to number of current divisors. Hopefully that makes sense. We're gonna check our current triangle number to see how many divisors it's got. We'll check the divisors of it, put it in this here, this will be a list. Then we're gonna take this list and calculate the length of it, which will tell us how many divisors we've got. And then we're saying if that number is bigger than the number that we're looking for, then if that number is bigger than the previous biggest number, then our new biggest number is equal to that one. Then once we've done that, we're going to say if current most divisors is bigger than our target number of divisors, then we just want to break, we want to get out of this while true loop. If not, then triangle number and index equal next triangle number, and then it should call this again. So that there should work. I'm now going to change this number to 5, because in the example 5 is the number it gives. So let's try this. Okay, so it ran without errors. Now I forgot to return anything, so down here I'm going to say print, and then we want to print So we don't want to print it there. What we want to do is in here, before we break out, we want to say print triangle number, because basically this will have found a number that is a new max. So this is going to print out all the new steps, sort of. You'll see in the output. So no, sorry, that wasn't in the place I expected it to be. So yeah, I'm going to put it there, and now you should get like, so we get 1 because that's when our number of divisors changing, then 3 because that's when it's changing again, then 6, and then the next time it changes 28. So if you look over here at the answer thing, you see it changes at 1, 2, because each time we're adding a divisor, then it's 6, and then it doesn't print out 10, 15 or 21 because all these still have only 4 divisors. But then it prints out 28 because 28 has 2 more divisors. So if I change this, if I change the target number of divisors to 500, we should see now, hopefully, we end up getting the answer. So actually what I'm going to do here, I'm going to cancel this, and I'm going to, every time this is printing, I'm going to print out the current Morse divisors as well, just so that we can keep track of how many divisors we've actually got. So you see we're up to like 112, 128, so the reason this is taking so long is because of this thing down here, this thing, where we're not actually going up to the square root of it and then checking. We're not doing this in any particularly clever way. This is just like a brute force way of finding divisors. So you can see this will actually work. We've got like 144 down here. It will eventually find one with more than 500 divisors, but it's going to take a long time. So what I'm going to do, I'm going to stop this. Actually, no, I'm not. I'm going to leave that running while I code in this cleverer bit of code over here. So I'm going to say while potential divisor is less than the so I'm going to say sqrt for square root is equal to number to the power 0.5. Now I'm going to say square root equals, I think it's seal or we'll do floor instead. I can't remember what the floor. Okay, one sec while I Google it. Yeah, it's seal. So we're going to call seal square root. What this does is it just rounds it up to the nearest whole number, just so we get the like a nice round number, and so that we include all the possible factors. So while potential divisor is less than square root, we're going to do all this good stuff. Now before we return it, we need to find the other half. So what we're going to do is we're going to say so this is going to be half divisors. Oops. That's going to go there. Now divisors equals an empty list. Now for I in range then half divisors. No, actually that's wrong. So for divisor in half divisors, we want to add this divisor to our list, and we also want to add its counterpart. So what we want to do is we want to say so divisors here I'm going to make equal to half divisors, just so we've got the first half in and then there's no need to append them. What I was going to do was append one and then append the other half, but I'd quite like to have them all in order, so that's what we're going to do here. Now, actually it's still not going to put them in order because the second half's going to be in reverse. Don't worry about it, doesn't matter, it's still going to work. So, for divisor and half divisors, so for each number in this list that we've got of divisors, we want to say divisors dot append, and then what we want to append is our number divided by the divisor, and this will give us a new divisor. So if I print out divisors down here and I print out divisors up there, and then I change this number again to 5, save that. I'm going to cancel this now. You can see it's at 240. It would get there eventually, it's just going to take a long time. So save all this. Now, seal is not defined. Why is this not defined? Oh, it's a math function. Okay, so import math. This is just obviously another module we're going to be using. I've showed how to import modules before and what they are. I've showed a little bit about it anyway. So seal, we want math.seal. Seal is a method in the math module. So hopefully that works. Now we're stuck in an infinite loop. Why? Why are we stuck? So printed out 2 empty lists. Now the empty lists are going to be this divisors list. Oh, I think it's stuck in an empty list because we are dividing. Oh no. I'm just going to print divisor right here. Okay, so why is it just looping over this function with 1 and 3 constantly? I'm going to import time a sec. And I'm going to add a sleep down here. What sleep does is it just makes your program stop for like, I'm going to put in 1 second just so it doesn't fly through all these loops. So we get, well, so it's stuck in the loop in here it seems like, which I don't understand because half divisors isn't an infinitely sized thing. Interesting. So I'm going to print out divisors. Yeah. So you see we're actually just adding 1 and 3 over and over and over, and I have no idea why. Why is it looping over the same thing repeatedly? So So I think what might be happening is I think this half divisors, when I'm assigning it to divisors, the plan there was so that I can append to divisors without affecting half divisors and without making this list longer. But I have a feeling that that list is actually getting longer, and I'm not sure why this is happening. But if I print out half divisors, you'll see I think it's going to be the same, getting longer. Yeah, it is. You can see half divisors is doing the exact same thing as divisors is and growing. So because our list's growing as we're adding to it, obviously that's not ever going to work out. So what I'm going to do is I'm going to say I'm going to try and go through the list backwards if I can. Not sure if this is going to work, we'll see. So if I do that, there we go. So going through it backwards is working fine. If I cancel this, I can get rid of all these prints. I can actually get rid of this all half divisors thing and just call it all divisor, but I'm not going to just because I've got it working, and I'll go back in a second and do that. So I can get rid of this sleep, I don't need that anymore. Get rid of this print, get rid of that sleep. Okay, so let's call that. So you see we get 28. Not sure where that 6 came from. So that's the current most divisors, I think it is. So if I now change this number to 500, it should work. So you can see we're up to 320, like instantly. 480, and we're now looking for probably one more number. There we go. So 576 is the minimum number of divisors, like the number of divisors that first goes over 500. And our answer is this number right here, so 765,765,00. Now we look at our answer, 765,765,00. Now that's it for this problem. There's the answer if that was all you were looking for, and this is how you do it. I'm not going to do it this video. I am actually going to end this video now, but I am going to have a think about how this thing was breaking. So the I'm not sure why divisors equal to half divisors was creating some sort of pointer to go there. I'll try and get an answer for you on that. Maybe put it in another video or something like that. It's definitely interesting, but what I would take away from this is if you're going to loop over some sort of list and then be appending to the list, loop through the list backwards so that you don't end up infinitely like going through your list as it's growing. Looping through backwards generally solves all them problems. So yeah, I definitely recommend doing that. Other than that, that's about it, I think. If you've got any improvements or anything you'd like to make, feel free to make them. Let me know what they are and how you did them. I'd be interested in hearing about it. But yeah, that's going to be it for now. If you liked the video, like it. If you want to see more, subscribe. Thanks for watching, and I'll see you in the next video.